Analyze math and history, and we're going to be taking a look at compound inequalities. So, in this video, we're going to understand and learn about what inequality is, and we're also going to learn about union and intersection. So, we have been learning about in the past, even when you were in your young years, that 6 is less than 10. And when we, in our high school years, or middle school years, we would have understood that x is less than 10. That is really easy to us because it can tell us which is less and which is greater, or which is less or more. But what happens if an inequality that has two signs in it and two numbers show up? So we have this, 45 is greater or equal to x, and x has to be less than or equal to 60. And x is greater than 8, or x is less than 20. So these are examples called compound inequalities, because a compound inequality is when there are more than one sign and more than one number, just like what we learned in the past years. So, there are two types of compound inequalities. Let's investigate the first one. To understand the first one, we can understand that we can have the x be trapped by red bars, because there are two parts of reading this equation. There's 45 is greater or equal to x, and x has to be less than or equal to 60. So there's pretty much a bare minimum, and there's pretty much a bare maximum. So x has to be more or equal to 45, and x has to be less than or equal to 60. So we can find out and understand that on a simple number line. So it says in the first part right here that x can be 45 or more. So we can bubble in 45 because it's telling us x can be 45 or more. Then we can go this way. But it also says that x has to be at least 60 or less. So pretty much x can be 60 or less. So we're going to put another bubble right here and connect the two. So x has to be within the middle or at 45 and 60. So this is one example of a compound inequality. We can definitely find this example in a speeding limit or a traffic law that requires like a speeding limit and a minimum limit, because you might have seen signs on a highway or even the road that says speed limit, and it will say a number like 60 miles per hour. But if you're living in the UK or other countries, it will be used with kilometers per hour. So if you go over 60 miles per hour, for example, then you'll get a ticket. But it's actually possible to get a ticket by going under the limit. If you go under 45 miles per hour, then that will tell you that you'll also get a ticket for going too slow. If you go too slow on a highway, then you'll interfere with the traffic flow and you will cause an accident waiting to happen. So it's possible to get a ticket by going under the limit, or under the minimum limit.
Whoa, did you see that? That guy wasn't just going fast. He was going totally fast.
Huh? Oh no! The cops are after us! What are we gonna do?
What? Sorry, I couldn't hear you over that siren.
No, there's a helicopter after us!
What's that? I couldn't hear you
This kind of problem is called an intersection. And the symbol for an intersection in mathematics is an upside down U. So pretty much we can say that 45 is greater or less than 45 is greater or equal to x, and x is less than or equal to 60. That is an intersection. The reason why we like to call it an intersection is because if you make another number line, if you have the green line representing the 45 is greater than or equal to x, that is telling us that 45 is here, but is going this way. And for the second part, x is less than 60. If 60 was right here, then we have a dot filled in right here, then it'll go this way. And the two lines are pretty much intersecting with each other. So that's why we can call it an intersection. X can be 45, 60, or in the middle. So this type of problem is an intersection. But what happens if we find this kind of problem? X is greater than 8 or X is greater than 20. Many people think that this will become as a no solution, because the thing is, many people will be like, how can a number be less than 8 and the same thing as more than 20? How can that work? But the thing is that that's actually incorrect because of the word or. So the equation is saying a number can be less than 8 or a number can be more than 20. If we graph that on a number line, let's say 20 is right here, and we have 8 is right here. So pretty much it's saying that x has to be less than 8 or x can be greater than 20. So we can put x in for here and x in for here. Any number like 7 and below can count for x, or any number above 20, like 21, 22, and more, that would still also count, because this kind of problem only lets you to slack off the work, because they're saying if one works, that's awesome, but if both work, that's still okay. What really matters is only if one number for it to work. Like for example, what if we insert 5 in for x? 5 is going to be less than 8. Or 5 is going to be more than 20. Since 5 is not more than 20, we can cross it out. But the problem will still work because at least we have one working answer. That is going to be called a union. This kind of problem is called a union, and that represents U as the symbol. So this is going to be union for this. So pretty much it's going to say x has to work for at least one of the problems. Another way of thinking it is, imagine you're at Chicago Union Station in Chicago, and there are two trains. One train is going east, while the other train is going west. What the thing is, since it's a union, you want to take the train that's going east. So at least one of the trains is going east. That's the train you want to get on. You don't want to go on the train that's going west, because that will go in the opposite direction. So you see how one train will work and the other one won't? A union allows you to only have one work and the other not, but it would still count. This is another example of a compound inequality. So we have learned the intersection and the union and how they are different. Thank you for watching How Penalized Math Industry. Like and subscribe.